Good day, everyone. Thanks for joining today's class. Today, we're considering calculation on concave mirror involving an object placed at the center of curvature. And the center of curvature is represented with letter C. And when you see a question like this, you'll not be told in the question that the object is placed at the center of curvature. But after calculating the object height or the image distance and is of the same distance, if the image distance is of the same distance with the object distance, is now referred to as object placed at the center of curvature. And also the height of the image must be of the same size as the height of the object. Now let's see the question. An object of height 5 centimeter is placed at 20 centimeter from a concave mirror. And always know that under concave mirror, the focal length is positive, but under convex mirror, the focal length is negative. You'll be given the focal length. The question it will not be put as a negative 10 under convex mirror. You just be told that the convex mirror of focal length 10 centimeter. But what you need to know is that the focal length is negative. You introduce your negative sign. Okay, let's go. An object of height 5 centimeter, that is object height. Let's use OH. First, let's write the parameter OH equals 5 centimeter. Is placed at 20 centimeter from a concave mirror. Here's the concave mirror. This concave mirror is placed. Okay, this is the object height, which is 10. What's given to us? It's given us 5 centimeter. Is placed 20 centimeter from the concave mirror of focal length 10 centimeter. Don't forget, when this is at the center of curvature, you're going to see it that it's of the same height as the object, that is the image height. Now, let's just do the calculation first before we know if it is at the center of curvature. Okay, the object height is 5 centimeter, placed at 20 centimeter from a concave mirror, that is the object distance, because the object that is placed at 20 centimeter, that is object distance. And yes, we use U to represent object distance, and it's 20 centimeter. Okay, now focal length F equals 10 centimeter. What is the image height? Image height, that's what you are looking for. And don't forget that we have a formula that says magnification equals to image distance, which is V, over image distance over object distance, equals to uh, image height over object height. You see, we have the object height, we don't have the image distance, we have the object distance, which is U, we don't have the image distance, but we have the object distance, we have the focal length. Let's use the mirror formula so that I can get the image distance. When we get the image distance, we can now relate these two equations together. Okay, these two expressions, these two fractions, you can relate it together, because magnification is equal to image distance over object distance equals to image height over object height. Always know that the image is always at the top, the image height is at the numerator, while the object distance also at the numerator. Don't make mistake of taking the object distance to the numerator. No, image is always at the numerator. Okay, now let's use the mirror formula. Using mirror formula, want to use the mirror formula to get the image distance. Mirror formula goes as 1 over F equals to 1 over U plus 1 over V plus 1 over V. Now what's the focal length? Is 10. 1 over 10 equals to 1 over u. 1 over, what's our u? Object distance, that's 20, plus image distance, we don't know it, 1 over v. I'm going to still draw the diagram, but let's finish the calculation. Now, collect the left hands. Let's take 1 over 20 to the left hand side. 1 over 10 minus 1 over 20. 1 over 20 is positive, but when it crosses the cosine turn to negative, equals to 1 over v. Or the now say 1 over v, you can take 1 over v to the left hand side. 1 over v, still the same thing, equals to 1 over 10 minus 1 over 20. Or the LCM? LCM is 10, is 20. LCM is 20. 10 in 20, 10 goes in 20 2 times, 2 times 1, that's 2. Minus 20 goes 21, 1 times 1, 1. You have 1 over v equals 2 minus 1, that is 1 over 20. You cross multiply, v times 1, that's cross multiply. When you equate fractions together like this, is to cross multiply. V times 1 equals to 1 times 20. V times 1, that's v, equals 1 times 2, that's 20 centimeter. Can you see that the image distance is also 20 centimeter, while the object distance is 20 centimeter? That means that the object is placed at the center of curvature because of the same distance from the mirror. Okay, now let's go. What we are looking for is the image height. Let's know whether the image height will also be of the same height as the object height, because when the object is placed at the center of curvature, it will have the same height as the image will have the same height as the object height. Okay, let's confirm that and let's equate it. Magnification equals v over u equals image height over object height. Now, what's the image distance? Image distance is 20 over object distance, each 20, equals to image height. That's what we're looking for, image height over object height, that's 5. From here, you cross multiply because, but before then, let's cancel out 20 here, 1, 20 in 21. It is 1 over 1 equals to image height over 5. Cross multiply, cross multiply. Let's cross multiply. Here, cross multiply, you have image height times 1, that is image height times 1 equals to 5 times 1. Image height times 1, that's image height, equals to 5 times 1, that's 5 centimeter. Can you see that the image height is of the same height as the object height? Yeah, let's now draw the diagram, the ray diagram of when an object is placed at the center of curvature. This is the mirror, concave mirror. The object height is 5 centimeter from the question. This is the principal focus. When it hits the mirror, concave mirror, pass through the principal focus. Okay, it's the ray diagram. Now the other one, before touching the first ray diagram, the arrow touches the mirror and pass through the principal focus, while the second ray line pass through the principal focus and come back. Okay, this point, this is just a sketch. Which is of the same height, which is 5 centimeter. This is the image height. Don't forget that the distance is 20 centimeter. Okay, the image object distance is 20 centimeter, and image distance is also 20 centimeter. That's why it forms the same height and also the same distance from the mirror. That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates, and also don't forget to leave your question in the comment section. Thanks for listening. See you in the next class. Have a wonderful day.